crazy awesome programming right out of the box. But as you can see, the top actually comes off, the cage comes off, and there's a whole lot of other stuff you can do with it. So I will start by giving you a quick tour of the sensor suite. So right off the bat, you can kind of see down into the robot. You'll be able to see the PCB layout. These are the motors and the encoders and the gearbox. You can kind of see all the mechanics of what makes it work. We've got an ambient light sensor right here, which allows you to write programming based on lux values.
Absolutely.
We've got a IR sensor on the front, transmitters and receivers on the sides and also the back for bot-to-bot communication, robot follow, swarm programming, and all sorts of stuff. We'll get into that in a little bit. And then we also have a color sensor on the bottom. So this is the same technology that we have built into our Spectrums rings.
Absolutely.
So you want to talk a little bit about the color sensor?
Sure, sure. Yeah, absolutely. So the color sensor is really interesting because the way we placed it on the floor with these couple LEDs to actually shine some light on the different textures and colors that you see as Rover is driving by, you will be able to have some interesting algorithms such as, hey, if I see the color red, I want to make a left turn. If I see the color blue, I want to make a right turn. If I see the color green, maybe I want to stop. So this opens up a new realm of motion and color detection that you can combine to actually solve mazes. You can actually put a perimeter in which Rover is going to stay in because it will see, oh, this is a color I'm supposed to go on. Maybe I'm just going to turn around. So there are a lot of different options that you can explore by having a mobile color sensor like that. So I want to talk about maybe the driving for a little bit and why Rover is unique in its own way.
Sure.
So Rover has two very important sensors set that make the driving very unique. So the first sensor set is the encoders that tells us that how fast the wheels are spinning. So for instance, if you're trying to drive in a straight line and one wheel is going faster than the other, well then we can sense that and compensate for the fact that this wheel is faster by either putting more energy into the other wheel or slowing down the first one, so it actually drives in a straight line. And speaking of straight lines, the other sensor set that we have, it's an IMU, so it has an accelerometer and a gyroscope, and these allow us to have an understanding of what angles the robot is sensing. So for instance, if it's asked to go at a yaw of value 0, and you can see it drifting a little bit because of the terrain, because of the different elements outside, the rover will be able to detect that and actually adjust for that loss of heading and compensate and go back to 0.
So why is that important when you're building like a robot project?
So this is super
compared to like, say like another tank bot.
Right. So this is really important because usually if you buy a threaded platform and you're building the code yourself, you only have access to the power that goes to your motors. You don't actually know your different heading. So if you were to send pure power and the same pure power to each motors, you would actually not necessarily have a robot driving straight because of the difference in the way the mechanics work and the difference in the terrain that you're actually noticing. So Rover is unique in the way that if you want to drive a straight line, you only need to send one command. You say drive, direction 0, speed 0 to 255, and it just does it.
That's cool. Yeah, so that's kind of one of the main unique features about Rover is the control system, and we've been tuning this and refining this control system for 8 years, and we feel it's the best control system out there. A lot of times you'll hear us say this is a professional level robot at a entry level price because we're selling it right now for $199 on Kickstarter. That's a very limited pricing that we're only going to do for the next 28 days. But the capabilities that this robot has are above and beyond any consumer level robot that we've ever seen. Yeah, so maybe you could talk a little bit about what are some of those like more professional level capabilities that Rover has like related specifically to the control system, like arc, drive to position, and stuff like that?
Absolutely. So having such a refined knowledge of where the robot is going at any time and how fast the motors are spinning, which direction the angle is taking, allows you to do some very fancy driving I guess, edges and arcs, for instance. So one of the basic problems that we like to solve is, can this drive in the perfect circle? And in order to drive in the perfect circle, you have to be able to understand your exact forward speed and your exact turning speed and match both of them and make sure that they're consistent across the whole circle. And that is something that Rover is actually really good at because of all the extra sensing and the control system that we have in there. And if you want to do a slalom and some figure eights, that kind of stuff, you would just chain different arc commands one after the other to actually achieve that result.
That's cool. Awesome. So let's move on to a couple of the other features we have that I will point out. So Rover comes with a 4,400 milliamp battery that's removable and rechargeable with USB-C. The battery door is here. The battery will pop out, and you'll be able to charge it and put like a freshly charged battery in it while you're running, other programs.
So for those of you who are familiar with what an amp hour is, it's a lot of power, and there are like 4,400 milliamp hours in there, so it's like four amp hours. So to give you a comparison, Bolt, which had double the battery life as Sphero, is 1,250 milliamp hours. So basically Rover is 3.5 times bigger battery than Bolt has, which gives you a lot of playtime.
That's cool. So yeah, what does that mean actually for charging and playtime, and what type of times are we talking for the user?
Yeah, so the playtime itself depends on what you do with it. And there's something that we haven't covered yet, which is what else can you do with Rover besides the driving and using the sensors and using the app that Sphero provides with it. So we're going to cover that in a little bit, but the point I'm trying to say here is that the driving and the sensing takes a certain amount of power, but the more you drive it, the less battery life you're going to have overall, right? So depending on your application, you can have from an hour to 2 to 3 hours if you're driving really slow, if you're not really using it for motion, but more so for sensing.
Absolutely. So, but it is the biggest battery we've ever built in any of our products, and the fact that it's removable and rechargeable gives the the user a lot more flexibility there.
And maybe we should talk about why we chose to make it removable, because this is one of the questions that we get usually. Yeah. So we believe Rover will be a tool for people to actually build a lot of amazing things. And every tool has a battery that's swappable. You can change it so that when your tool is out of battery, you can just replace the battery and go on to the next cycle. And this is why we chose to actually have this battery removable instead of having to plug onto the robot itself.
That's awesome. Cool. And then also just a few more of the out-of-box features is we have 10 individually addressable RGB LEDs. So the sides, the headlights, the back, the other side, they all light up. They're individually addressable, which means you can write all sorts of fun programming programs to change the color based on different sensor data that's having. So like some fun examples that we built was like chameleon mode with the color sensor. Do you want to talk
and that was
about
a really fun one. So basically, since you have the input of the color sensor telling you the raw R, G, and B values that it's reading from the color cards or the texture that you're on, you can basically say, hey, why don't I connect this to the output towards my LEDs so that my LEDs will have the RGB channels of the value that I'm reading from my color sensor. And this is something that you can see in the video, on the Kickstarter video, on the YouTube video that we launched. Because you have the Rover driving on top of different color cards, and as it's doing so, its LEDs are actually matching the color it's actually reading. That's
really cool. So we're imagining people, writing programs where you can lay out, different colored construction paper around a room, and then have Rover autonomously drive around and do different things based on the different colors it recognizes.
Right.
Yeah, all sorts of cool possibilities there. So Rover works right out of the box with our EDU app, and that's the same app that controls our other robots, our Sphero Mini, our Sphero Bolt,
and the Spark Plus.
And the Spark Plus. And so that's a really, really nice thing because you've got this active community and this really rich ecosystem that has, thousands and thousands of programs that people have written, and it gives you all sorts of really great ideas to use this right out of the box, and then it also shares a lot of the same sensors as Bolt.
Right. And speaking of Bolt, I want to highlight the fact that one of the features that we introduced in Bolt was the infrared, and we briefly mentioned that Rover has infrared capabilities as well. So what does that mean? Well, just like in Bolt, Rover is able to send messages to other Bolts and able to detect them from different sides, actually follow them, and autonomously follow them, and also evade them, just like in Bolt. But we actually built the infrared on this platform to be able to talk with the current Bolts that we have. So both robots are actually able to interact, and if you were to send a message from Rover, Bolt can pick it up and have different interactions, and vice versa. So this will create a lot of different swarm, I think, applications in the future where teachers who already have a Bolt or two or a Power Pack, 15 of them, we'll be able to get a rover and send a bunch of messages and control, the kind of their ducklings on the side with them.
That's really cool. So we talk about swarm robotics a lot with this, and maybe you could give us an idea of like what are some of those implementations? What does that look like? Could I have, 15 pack of bolts in a room and have them all following a rover around? Like what are some things you anticipate people doing with that if they really wanted to dive in?
Absolutely. So we designed the infrared to be as flexible as possible for people to use. And the infrared works in the following way. There are 8 different messages that you can send, and they all have a different meaning, but you pick what kind of meaning you give to it. So for instance, you say, oh, well, if I read the message number ID number 3, it means that there is a rover nearby that I want to follow. And then you're going to try to look at your sensors to go left and right depending on what kind of following you want to do, or evading if you want to go away from that. So as far as applications, there's a lot of maze solving possibility. There's a lot of behavioral possibilities with swarming, thanks to that infrared that you have not only on rover, but also on bolt.
That's really cool. Sweet. So just to kind of do a quick recap of the out-of-box features, because I saw a question come in yesterday on our Kickstarter live stream, is what can you do with rover out of the box? So out of the box, you're going to get a rover with a removable cover plate and a cage. You're going to get what we're calling a mounting plate, which we'll get into that in just a moment here. You've got ambient light sensors, high-resolution motors, great high gear ratio for fast driving, but also really accurate driving at slow speeds. It's all-terrain, so that means you can take your projects outside and do some really fun stuff that way. And then you've got the RGB sensor on the bottom that works very similarly to the Spectrum's rings. And then you've got the IR sensing on all sides, the IMU, the control system, and
the ambient light sensor.
Ambient light sensor, and then also the removable rechargeable battery, and then everything built into the Sphero EDU app. So a complete awesome experience, probably our most capable robot we've ever built here at Sphero. But here's the real kicker, is we spent a lot of time and energy developing what we're calling a universal expansion port on top. So that's what really sets this aside and is different from anything we've ever done before, is we're exposing a 4-pin UART connector here and providing 5 volts, 2.1 amps of power via USB-A, which allows you to do all sorts of stuff. So maybe we could talk a little bit about that and what some of all this stuff is up here.
Sure. So Rover was designed to be the platform for people to make, the platform for people to hack, but not only software hack, also hardware hack. And this is why we try to make it as flexible as possible on this platform. And this is, to give you an example of the capabilities of this expansion port, we actually created a bunch of kits here with some simple parts bought on SparkFun, for instance, for this guy. So we have an anemometer.
What is this here?
So this is an anemometer, so it measures the wind speed. So as the speed blows on this device, it actually spins the little wheel right there. And then the information of how fast it's spinning is actually transferred to the Raspberry Pi that you can see kind of hiding behind a roll cage to protect it a little bit in here. And the Raspberry Pi, which is plugged in the UART port and talking with the rover and actually getting power from there, will be able to interact with rover and send some driving commands to say, hey, it's kind of windy out here, let me go in a different spot. Or there's no wind here, let me explore a different area of my yard, of the road, or whatever. And this is really what these are about. We want to make sure that this is a platform that's easy to open. And for this guy, you just have to download the Raspberry Pi image that we will provide on our website. You just have to plug it in there, connect the UART port, plug in the USB power, and you're good to go. You can work on this project on your computer, on your desktop, and then plug it in on your rover, and you're good to go.
That's really cool. So you're saying over UART you can send data and roll commands to our chip on rover,
Absolutely.
Right?
So
and what about receiving? So how does that work? Like, what's the data flow there?
That is also working that way, but we designed we have an SDK that we developed specifically for Raspberry Pi, specifically for microbit. So we're working on all these different SDKs in parallel for the release, so that we can actually have back and forth communication between let's say the Raspberry Pi and the rover. And for instance, there's information that goes to the rover, which are the commands, the roll commands, the driving commands, changing the LEDs, but there are also information that goes back from the rover to the Raspberry Pi if you enable it, such as, I would like to stream the data I would like to retrieve the data from the color sensor and have it all the way back to my Raspberry Pi so I can make the decision on what to do with it. I would like to get the data from my inertia matrix unit, my IMU, so that I can make a decision on how far left or right I'm actually driving. And this is like the two-way communication that we enable for the users.
That's really cool. So, so we are here at the Design Center in Boulder, Colorado, where we built Rover. I'm surrounded by most of the brilliant engineers who contributed to this product. And I'm going to do a quick plug for our hackathon, which is this awesome event that we're hosting on Pi Day, March 14th. It's coming up in about 3 weeks. And we're going to actually fly some of our Kickstarter backers out here to interact with Rover, test out our SDK. Quentin's brewing up all sorts of really fun challenges that we're going to do.
Yes,
we're building
I am working on
courses.
that.
It's going to be really fun. So check it out. Check it out on our Kickstarter page. There's a spot to apply down under the hackathon section on the Rover Kickstarter page. And then I was thinking we could pull in a few of the people that helped build Rover and just talk a little bit about what they did. And we'll start with maybe Jeff. Are you down? You ready?
Sounds great.
So I want
How's it
to
going, Jeff?
introduce you guys to Jeff.
Hi.
Going to
Hi, guys.
Yeah, so thank you. And so maybe you could tell us a little bit about what you do here and what was your contribution to Rover, just kind of high level.
Yeah, definitely. So I work on the firmware team at Rover, at Sphero for Rover. And we're responsible for all of the code that runs on the robot. So we sort of do robot brains. We write the code that runs the sensors, the control system that Quentin was talking about, all of the following and evading with the infrared features. And we're also responsible for the communication that would go up to the Raspberry Pi or the Arduino that you can stick on top of the project.
Yeah. So what types of challenges did your team face when we're talking about incorporating like this insanely scalable world of open source hardware to interact with our robot? Like, how does that affect our firmware protocols? Like, how do we approach the battery life? Walk me through a few of those challenges and how we solve them.
It's been really exciting. I mean, the kind of biggest challenge right off the bat is there's just a ton of sensors packed in there. We're actually running 2 separate processors just to handle everything. Not just the protocol handling, but every single little bit that has to get flipped. Somebody has to handle that. Our protocol is already sort of set up to talk to almost anything, but now we're really hardening it. And one of the projects we're working on this year is to publish that API so that people, even if you want to step below the level of the SDK, you can talk directly to each processor on our system at the bit level. That's been super cool to work on that.
That's really cool. And then what about the color sensor? I know that you did a ton of work dialing that in for Spectrum.
Yeah.
So how does that translate over to Rover, and what could some of our users expect to do with the color sensor, and how'd you make it work?
Yeah, working on the Spectrums project was awesome. That was one of the things I did here this year, was to help bring their world into our world. And we took the time to calibrate every single unit so that it sees color the same way you see color. And that allows you to you could design a maze where the rover can actually see what's underneath it and react to things. You can tell the actual RGB value of the color as well as identify it as a color. You tell us, I have a palette of 6 things I'm looking for, and we can say, hey, I saw number 5. And you can use that event to go drive your programs.
That's really cool. Yeah, what else do you want to...
I think the firmware is a really interesting thing because there's a lot of small pieces of the puzzle that we've been working on for almost like 9 years now.
Yeah.
That are actually built up in that structure. So some of the code that we have for our IMU was designed a long time ago and still working perfectly.
That code is super interesting code. So we have these 2 sensors on board, the accelerometer and the gyroscope. And the accelerometer is sort of like when you ride in a car and you close your eyes and you can feel yourself swaying back and forth. You can feel force. And the gyro tells you angular velocity, so you can see how fast you're spinning in the room.
Right.
We have to take those things, smash them together, and on top of that, create the whole understanding of the map of the room you're in and where you are with respect to it.
So you're saying that if the robot is upside down, it will actually know it?
Yeah, absolutely. So
Wow.
it can know where it's pointing, what orientation it's in, and how fast it's moving.
That's pretty amazing.
That's really cool.
And is that the same tech as we had in Sphero before?
Yeah, it's actually the same tech we've had in Sphero, in Force Band when we were sensing people's arms moving around. And some of that's been integrated into really everything we've built here. We've been hammering on that code for really 8 years now. It's pretty baked.
And this goes to show that we've been refining the process, refining our tools, refining our different technologies.
Oh yeah,
and
this
it's all like baked into that amazing platform that we're now proud to actually show people.
Yeah, this is really sort of the culmination of a lot of learning over the course of the last 8 years. We're taking little bits from every project we've ever done and built this great platforms for you to go build the next robot that you want to build.
That's great. Yeah, actually, I did see one question come in from Joseph, and he's saying make sure you have a community on Thingiverse for making and sharing parts. So
that's right.
Yeah, so that's something we could talk to that looks like it's going to be a lot of fun for the users and for us. And like what sorts of things do you imagine people doing, and like printing? Like, what could people do? Like, how far could they go with printing stuff? And
really anything you could imagine. You want it to have a cup holder, you have a cup holder. You want to make a robotic arm, make a robotic arm. And because we've given you direct access to the UART and the USB, you can really control anything you want to build. Seriously, anything you can dream. All this stuff here was us just hacking away on fun projects.
Yeah, that's really cool. It sounds, are we back up on chat? It looks like we're having some technical difficulties, so we're not able to answer all the questions in real time, but we have a few that have managed to trickle their way in.
You guys stay tuned, we'll fix that real quick and keep your questions.
Oh, this is a good one. So
be there right away.
I can't pronounce that. Ranch Comanche Lanchin. That is a legit username.
I know that guy.
Really?
No, I don't know that guy.
He's asking, can Rover drive upside down? Does it realign to switch control automatically?
We actually have some experiments showing it driving up on its two wheels.
We call it twerk mode.
Yeah.
So you'll see actually when the cover plate is on.
Let's move this out of the way so they can see.
But it actually we built it so that there is clearance for when it's upside down, and now your sensors are pointed up, so it's going to obviously behave totally differently. Right now we aren't putting that on the day one user features where it's going to.
One of the great things about the way we do our firmware here is it's updatable in the field. So if you wanted to see something and you really cared about it, write us an email, hit us up on Twitter, and we actually might go build that. We like that stuff a lot.
Yeah, so there's all sorts of fun stuff we want to do there with the control system. So flipping it is theoretically and 100% possible and doable.
It would be awesome.
Firmware, drives upside down, and then all your sensors are pointed up. There's some cool possibilities there, and then also just driving upright like this is a thing that we experimented with accidentally with our Ollie board.
We sort of stumbled onto it while we were hacking, just making the rover. We started off with robots we had here, so the board was one of our Ollie boards. I don't know if you've seen the Ollie, but it's a super sweet trick robot. It goes 15 miles an hour.
That's pretty fast.
And when we stuck that board inside here, the thing just popped up and started twerking.
Yes.
So maybe we'll release that as a feature.
Yes, twerk mode. Okay, a few more questions coming in. So does Rover have to aim like other Sphero robots?
We're actually debating that right now because I just actually got out of a meeting about it. Because Rover has a clear front and back, you could definitely make an argument for not doing that. Also, we could go with the current method we have now where you aim in a ring. But we also have the magnetometer on board, so we can bring in the feature that Quinton helped design for Bolt.
Yeah, so Bolt introduced a new feature which was auto-aiming, so the robot knowing where north is thanks to the magnetometer, and the phone knowing where north is thanks to its own magnetometer, you're able to kind of align these two arrows and say, oh, my phone is oriented this way, and therefore my robot is oriented this way as well. And from there, you can actually have the two know how oriented they are against one another. And this is something that we also have in Rover. So in the Edu app, there will also be the option to do the auto calibration routine, so that if your phone is facing this way and you want Rover to be, aimed this way, you just press on the auto aim button and it will just like do the routine and actually know that as well.
So how does that, maybe you could explain how that works when you're trying to calibrate a magnetometer inside a robot filled with essentially magnets?
Sure.
How did you solve for that?
That's a great question.
That was a very tough problem that we've been spending a lot of hours on and doing a lot of research. But the trick that we eventually came up with was that the problem that we were facing is we were getting some noise from the different metal, but by turning around yourself, you can actually get a clear picture of the different projection of the field, of the north field, onto your different axes, and that gave us the information we're looking for. Like by matching to a sine curve, we're actually able to get that feature done.
That's really cool.
This is a pretty cool question here. Del Hagerwill asks if we'll be able to use the block code or JavaScript or communicate with the SDK.
All three of them.
All three of them. Also draw and drive. So you can start all the way from drawing a circle on your phone, and Rover will drive in a circle. You move up a layer to the block-based programming, where each block represents code. If I hit a thing, then do a sweet dance. Up to JavaScript. When we release the SDK for Raspberry Pi, you'll be able to program in a Linux environment.
Right.
And as I said before, we'll be publishing the actual raw binary API. So if you want to go build something totally crazy, get in the guts of the robot, we really encourage that.
That's awesome.
And this is because this is a robot for the makers. This is a robot for the hackers, but this is also a robot for teachers who want to push it to the next level for the high school class that want to use some Raspberry Pi that they already have in their curriculum. So we kind of built that robot around that for that reason.
That's great.
Yeah, this robot actually came up because someone here in the organization said, man, I wish we just had a platform I could hack on here in the office. And we all just sat around dreaming of what the perfect version of that would be. And that's how this robot was born. We started to see that this would be so great in the classroom to help elevate learning all the way up to, like we're talking about, these Linux systems and binary communication.
Yeah, that's true. So this started out as an idea internally just to have a platform to get creative on, and we're really anticipating that that's what you guys, the end users, will do. Is, you know, we've solved a lot of the hard problems, and you get to start with a functioning, you know, state-of-the-art control system, and then make it do whatever the heck you want. So that's really cool. Yeah. So thank you.
Yeah.
Thank you for joining
Thanks
us.
a
We're
lot,
gonna
Jeff.
maybe talk to a
Bye.
few other people. Thanks, Jeff. Yay. Dave Clark, you want to come chat? So we're just going to randomly call people up here.
Okay, never mind. We'll get someone else then.
What's up, guys? This is
Hey, YouTube.
Dave Clark. He's a senior mechanical engineer here. So speaking of how this thing was born, Jeff was just saying this was a pitch internally to build a robot. And, you know, some people might say, you know, it's a tank-treaded robot. No big deal. It's easy. You just put some motors in there and a battery and a gearbox and let it go. But that really isn't the case. So maybe you could walk us through.
Who said it was easy?
I think it was Quentin.
Oh,
Yeah.
Never mind.
Yeah. So walk us through. Like, how did you approach it? What were the first problems you wanted to solve? How did you solve them? And how did we land where we did with Rover?
yeah, I'm really happy with the way this thing turned out. When we started down the design path, we knew we wanted tank treads because that just affords you the maximum traction, maximum mobility, and the thoughtful details that went into this. When we started down the design, we initially had it symmetrical, top to bottom, left to right. Everything was symmetrical, so you could drive it like this or you could drive it like this, which you still can, but we knew that we wanted maximum ground clearance as well. So when you look at the profile of this thing, when you're looking at it from front on, you actually see that when you're driving it upside down, you have minimal ground clearance. It's just barely skimming the surface. So it can still do, well, this one doesn't work, but this way has maximum ground clearance. And so what we did is we actually thoughtfully made it asymmetrical so that you get the ability to climb over all kinds of fun things, but still you go up to a wall, there's enough torque, enough traction where you can climb it, we're gonna test out going vertical and then actually flipping over and then driving it upside down. I mean, those are fun.
That's cool. So speaking of torque, what sorts of weird experiments are you going to build for the hackathon and for future videos?
Yeah. Well, we've got a couple of things in the pipeline. So we run a lot of numbers on this thing. We ran speed calculations, torque calculations, and we know the numbers tell us that it can climb a wall. That sounds a little bit ambitious, but what we're going to do is next week, tune in YouTube next week, or next week to YouTube, and we're actually going to make special set of wheels for this thing, and we're going to climb it up a wall. We're going to use this robot with a winching effect to kind of get it to
That's
go up a wall.
crazy. That's so exciting.
Yeah,
Can't wait to see it.
I challenge you to get any other tank robot on the market to do that.
Climb it
All
to
right,
it.
all right.
No, that'll
Maybe
be
a couple
fun.
people have done that before. We don't know.
Yeah.
No, that's really cool. So how are you going to make the wheels? Are you just printing them, or what are you going to do?
Yeah, I'm going to basically take these exact same wheels, so we're still going to keep the treads because the treads kind of help keep it from sliding on the wall.
Right,
but
right.
I'm basically going to 3D print some pulleys on the outboard side of these things, and then what we'll do is we'll connect some rope to those pulleys, and then we'll just connect those to a couple of hooks in the wall, and we'll just drive this thing straight up the wall.
That sounds really
awesome.
funny.
Yeah.
Yeah,
Can't
that's
wait
cool.
to see it.
So maybe you could talk also a little bit about the motors and just everything inside, like how it all fits in, the center of gravity, balancing out where the battery was going to go, all of the different mechanisms that keep it together. You know, maybe even this whole mechanism here. Like,
Yeah. When we started out, obviously, if we look inside, these motors right here were chosen specifically because they fit. We knew we wanted a large amount of torque. We had a speed requirement. We wanted this thing to travel faster than any other Sphero EDU product.
Right,
So
right.
it travels faster than Bolt. It travels faster than Spark Plus. But once we got the form factor, we had to package this thing from the inside out. It makes no sense to try to say, well, how big a battery can we put in? We determined how long the battery needed to last, and then we made estimates on how much current draw was going to happen, and so we sized the battery first. Then we knew how much room was left over for motors and gearboxes and PCBs, and so that kind of drove the exact dimensions, but the general form factor was kind of determined based on looking at other robots and seeing what was out there. So these motors are combined with these gearboxes to give us enough torque. We've done experiments internally where we can drive up about 35 degrees. And also laterally, because the CG sits so low, the CG is actually almost exactly in the middle this way and this way. And so it can actually drive along something that's about that steep, and it can climb and descend without flipping over. If you want it to flip, you can get it to flip, but you got to go up to a wall and actually drive up it and flip over.
And you can see a lot of these features that are highlighted in the Kickstarter video and the YouTube video. We have done some fun experimenting with some wood, with some different textures, with some crazy toys, really, to go over. And this is really highlights the amount of torque that there is in the rover.
And so I've seen a couple of comments or questions about how heavy it weighs. Right now, the analysis shows it's about 1 kilogram, and that's supported by the 3D printed models. This rig right here, this is our roll cage, because we know people are going to be ambitious about where this goes, and there are going to be times when you want to roll over, but you don't necessarily want it to flip completely upside down. So when we designed this, we knew we wanted it to hinge in back and then press down in front, and then you would have a release mechanism up front. The whole goal was to make it user-friendly, intuitive, and basically really fast for you to be able to build your project on this mounting plate and then install it, connect up your UART and your power, and away you go.
awesome.
And the cage is really great for you to snap things onto, like kind of attach them one way or the other. And this is where all your creations, all your projects are actually gonna, be alive, right? Like on the cage,
like
that's
these.
easy to use. So
Right.
this one is one of them. It was kind of funny. So we want to experiment with a rover that has a bunch of solar panels on, and have a voltmeter that is hooked up to that, so that the more light there is, the more your needle will go up. So if I were to kind of mask it, the needle would move a little bit. So I'm sure it's a little hard to see right now, but that's kind of what the idea behind the kit and how useful the roll cage was actually to build that project.
Yeah, so we wanted it to be, aesthetically pleasing. So, like I said in the beginning, it will come with this cover plate and a roll cage, they're both removable. But then in the box will also be this mounting plate, and so you can see some of the projects that we built to make our Kickstarter campaign. There's all sorts of crazy stuff that we can do with them, and that we're really excited to see what you guys do with them. But we really wanted this to not only be, an aesthetic design language for Sphero, but also we want it to be super useful. So, we've got spot for servos, we've got spot for Pi, Arduino, microbit.
And then materials. I mean, let's not forget
Yeah,
about
sure.
the materials
That's
that
a
we've
good point.
chosen. The chassis itself is built from impact-resistant ABS. When it came to the roll cage and the mounting plate, the roll cage is made out of a very, very impact-resistant polycarbonate. I mean,
Right.
polycarbonate is one of the toughest materials, but we wanted it to be clear as well. And clear ABS doesn't perform as well as polycarbonate. So even within the class of resins and everything else like that, we went in and we analyzed all the different data sheets, and we picked the right material for this thing. I mean, the durability is going to be fantastic.
That's
So
amazing.
maybe we could Brian, can you come chat a little bit about the design? So we're going to have our industrial designer come over and talk a little bit about, what went into, the colors, the roll cage, why we designed it the way that we designed it. So thank you, David.
Thanks a lot,
I appreciate
Dave.
it. And while Brian's coming up here, it looks like we have a few more questions coming in. Ranch is coming back strong. Plans for extension toys like robot arm for Rover in the future. Absolutely. I mean, we're working on all sorts of crazy stuff that you can build on top of it. We do think of it as a platform, and on a platform there's just a million different things you can do with it.
Right.
This morning Brian designed a little just a straight up Lego topper that you could put on top. You can see some of the stuff here, so we definitely have plans there. So thank you for your question. We're going to give you a Rover hat, which they'll send out to you. So send us your address, and we will we'll send that out to you. And then Bry Guy, what do you think, man? Oh,
Hey guys.
hey,
Oh, hello.
hello there. So
Hi, guys.
This is Brian Hain. He is our industrial designer. Maybe you could walk us through just a little bit about why is it white? Why are the treads gray?
Sure.
Why do we design this the way that we designed
And like
it?
the eyes and stuff. All these tiny details are actually give a lot of personality to the robot.
Totally,
So I want
totally.
to hear all about it.
Sure. So a lot of the design process for Rover, there's two parts to it. There's the aesthetic side and there's the functionality side. So whenever we start a project like this, we have to work from the inside out, as David said. So we're going to go out into the field. We're actually going to figure out what people that are using this product actually need and what form factor is going to work for them. And I don't know if you recall, the original sculpture of this was just made out of foam. We actually just hacked together a really quick
So
little
funny.
brick, and we knew what size we needed it. And as it changes, that's when things get really fun. So as we start building this in CAD, we can iterate on different sizes, build it around the battery, around the board, around some of those primary features. I don't know if you guys have ever seen that classic design process illustration where it's like we want to get from here to here, and then the path to it is just crazy. And I don't know if we recall some of the primary interactions that we had with this. So first and foremost, we wanted this to be a tool. So all the touch points, for example, we worked diligently on making sure that this switch, for example, this release for the mounting plate and the cover plate just felt absolutely perfect. Simple things like, as this is snapped into the robot, that it's impossible to get the cage off. But when you pull it off, now you can remove the cage easily. So things like that add a little bit of detail and just show people how we think, because again, we want this to be a tool. And David, I don't know if you recall, when we started doing this and we knew we wanted a removable battery, we actually went out into the world. We went to hardware stores. We looked at electric
every power tool out there.
lawnmowers, power tools,
Weed whackers.
everything, weed whackers. Yeah. So the point was we could actually figure out, okay, where can we pull in mechanisms maybe from outside of the robotics world that are tried and true and work really well, and then adapt those to our needs. So we have to build on the work of others. As far as the overall look, some of the nice features is any touch point you see is going to be the Sphero blue. So that helps people see where they're going to release something. Imagine a child sees this for the first time and they're getting interested in it. They're going to know to push that button. As they get into the battery door right here, we knew the release needed to be blue as well, and just maintain that visual language throughout.
So tell me a little bit about like just the color, for example. Like why didn't we make it like black or big blue, or like what was the thinking around that?
I think with stuff like this, it's really important to let the color be in the background and let somebody's self-expression come through. That's really important because we know people are going to hack on this. They're going to add things to this, and we don't want it to get in the way visually of whatever experience they're doing. We also have these LED strips on each side. Everything is full RGB LED. So the eyes, the strips on the side, this LED strip right on the back, and those are individually addressable. So people that are using this robot can make them each individual colors, or if you're using the color sensor on the bottom, perhaps that's going to reflect what color you're driving over. And so we wanted those to shine first and foremost, and we wanted the chassis to get into the background. And on that note too, if you look at some of our previous robots, I don't know if you guys have seen Ollie.
Oh, that's a fun one.
Yeah. So some of the aspects that we carried through on Rover, we wanted to use a white chassis. We wanted to carry over the tread aesthetic. So Sphero has this nubby tread. We also, if you look on a Sphero ball, there's a nubby cover that can be put over it. And so we wanted to make sure to carry that through on this. So at a glance, somebody will look at it and say, oh, that's a Sphero product. And I remember just all the different tread colors, textures, durometer, which is how hard the material is to get the right friction. That was a fun part of that.
And speaking of blue treads, do we have any plans to actually make blue treads
Well,
like that?
we do. So that's a fun part. On the Kickstarter, you'll see there's the option for a blue roll cage and blue treads. So if we hit 500,000, we get the blue treads.
Wow, okay.
Which is cool. And if we hit 1 million, we'll release a blue roll cage, which will be semi-transparent, similar to this, made out of that same material. So it's actually going to be strong too.
Nice.
Yeah.
That's cool. Awesome. Well, thank you, Brian.
Yeah.
Thanks
You're
a lot.
welcome. Thanks,
Appreciate
guys.
it.
Yeah. So, a lot goes into this from firmware to design to software. There's just a lot of thinking and a lot of people dedicated a lot of time and thought to make Rover what it is.
And it's all about the details in this case. So as we're spending the time, we are looking at the details to make that experience absolutely amazing for you guys, so that you don't have to worry about the parts that are usually bothering you when you're coding and
Are you
hacking.
guys doing a thing? Shoot,
Hi,
sorry.
Julie. So we want you guys to focus on the fun part, and we take the hard part away, so that you don't have to worry about it.
That's awesome. So we have a few more questions coming in. So let's see. Here's a good one from. Let's see. Is there a hardware input option interested in hacking using a companion computer managing machine vision input? If so, what's the protocol?
Yeah, so just like if you put a Raspberry Pi, which is basically a computer, and you would tie it up into the UART expansion port or into the USB, you could actually tie a real computer to that. There's no problem doing so, and you would write your own application on your computer to actually have it drive Taver to that. That should be no problem.
That's a great question. And then I think this is the same person is asking, is there going to be an image with all SDKs, et cetera, included? And so, yeah, that's definitely part of our plan.
Yes, we're going to build that
we should
image for you and release
let's
that.
grab Anthony. Maybe
Sure.
he can talk a little bit about that. So we're gonna ask Anthony, our software and SDK guy, to come out.
How's it going, Anthony?
Doing good. How are you gentlemen doing?
Doing
Doing
great.
good, man.
All right.
So we got some questions coming in around the SDK, and so maybe we could talk a little bit about some of the stuff that you're working on for Rover, what we're building to provide the users and the hackers, and what can they expect when they get one of these.
Sure. So we're for launch, we're going to be building out a couple SDKs. One for microbit, which is actually 2 pieces. We'll be able to provide an experience if you want to do just block programming through MakeCode, or if you want to dive a little bit deeper into Python, you can actually use the Python editor, which is using MicroPython to interact and put microbit on the Rover and do some programming that way. Nice. So that's microbit, and then on launch we'll also have Arduino support, which will be a C++ library. Again, allowing you to build your own application, whatever your imagination is, whatever your dreams are that you want to build. And the third one, which will provide a really deep experience on, is with Raspberry Pi. And with Raspberry Pi, we'll provide a Python library, as well as a Node.js TypeScript library. So if you want to interact with Rover remotely with your Raspberry Pi on Rover, running a web service, you'll be able to do that. Or if you want to just build an application that's running locally on your Raspberry Pi that's mounted to Rover, that's doing some type of computer vision or anything like that, you'll be able to build those out with our SDKs.
That's cool. So you mentioned being able to drive using a web server. So what does that look like? Like what sorts of crazy things could people do with that?
Sure. So, I mean, if you're just on your local Wi-Fi at home and you want to build, we'll build a sample that you can basically just continue to build off of. So a basic web page that has, a remote that's just up, down, left, right, or if you want to do your keyboard keys or something like that. Mm-hmm. But essentially you can have the Raspberry Pi with the web server running on it and open up a browser on your phone or your other, your tablet or something, and then be able to just drive around, drive over Rover around through your house. And if you have a camera, then you can actually embed the camera stream onto that web page and just drive Rover around and kind of peek around room to room like that. And
That sounds awesome.
put some LEDs on there so you can have some, you know, some additional lights for when you're driving around at night.
That's really cool. So, and also, again, so we have a lot of plans coming up for this hackathon. So, again, if you're tuning in or you haven't heard about the hackathon yet, we are going to be doing a really fun event with Rover on Pi Day for our Kickstarter backers. There's a place where you can apply halfway down our Kickstarter campaign, and we're doing a lot of preparation for that. But maybe you could talk a little bit about what we're going to be doing for that and kind of how that's going to inform, you know, what we build out for the final product release.
Yeah, Quentin and I are tag teaming the hackathon
right.
and really trying to put together some challenges and activities and really make it for a fun-filled day, but also make it challenging in the sense that we want to see what you guys can build with Rover. We have some ideas of different, like I said, challenges that we want to put on the table and say, okay, well, here's what we'd like you guys to try to do with Rover and the Raspberry Pi, and here's a bunch of different sensors, and let's see what ideas you guys can come up with and see how actually you go through implementing those ideas using our SDK.
Yeah, and we're going to be live streaming this event too, so tune in when it happens. It will be on Pi Day on 3/14. We're super excited to host this and have four people come and like put their hands on for the first time on Rover before everyone else.
And there will be pie.
There will be
There will
drinks,
be pie.
Pizza pie or regular pie?
but all delicious pie.
All delicious pie.
Yeah.
Fruit and cream.
Yeah. Okay, so while you're still up here, if you don't mind, so there's a few more questions coming in. Let's just take a moment to go through a few of those and see if there's
Sure,
anything
sounds
there.
great.
So another one coming in from Ranch. I love that username. It's fantastic. So webcam support planned on the official app.
At launch, we will not have necessarily a like webcam integrated into our EDU app, but we will have samples as part of the SDK for Raspberry Pi at a minimum to show how you would integrate a PiCam with your Raspberry Pi experience on Rover.
That's amazing.
That's great. And then Christopher Rich, when can you buy them in the store? I'm going to give you a hat for asking that question. So
great
send us
question.
your info. Here you go, guys. We'll send that out to you. Thanks for asking, because we even forgot to talk about that in yesterday's Kickstarter
Right,
live
right,
stream. So Rover is for sale right now on Kickstarter. It's at a very special Kickstarter price at $199. We're going to be shipping this in the fall of this year, and when it hits the stores, it will be $249. So I would suggest to get it now while there's still some available on the Kickstarter campaign. But if you don't get a chance to do that, they'll be available in the fall. Let's see if we can find a few more here. So here's a few that we missed. So I'm a newbie to robots. What might you offer a Rover webinar or video for newbies? Thank you for any assistance you can provide. So maybe
question.
like, you know, if I hear robots and coding and stuff, that's like, maybe that's me, but what could that type of user do with Rover just right out of the box?
Yeah, so right out of the box, we have an EDU app that's available on 5 different platforms, iOS, macOS, Android, Windows, and Chrome OS. So to get started, getting Rover, power it up, connect with one of those apps with the EDU app that we have available, and you can kind of start off with block programming and being able to program Rover using basically Scratch blocks is what we have integrated into our EDU app. And once you feel like you've kind of mastered block programming, you can graduate into JavaScript programming again within the EDU app. And when you're ready to venture out from there, you can get a Raspberry Pi, a microbit, an Arduino, and then be able to just continue learning and continuing evolving your learning and education about robots.
And I do want to mention that on the EDU app, we have a way to transition in an easier way from the blocks to JavaScript, as when you write a block program, you actually have a little option on the menu on the top right to view the JavaScript code. So if you're trying to learn JavaScript in a very simple way, you can actually drag a couple of the key blocks, the for loops, the if statements, and see what they look like in JavaScript. And then you can basically get a sense of like how every block is actually programmed on the behind the scenes, right?
Absolutely.
And when you're ready to start your very first program in JavaScript, you have that extra knowledge so you know where to start.
That's great. Here's another one that kind of dovetails into that. So Dennis, are you planning to provide Python programming support?
Absolutely. Python will be supported in both the Raspberry Pi as well as the microbit SDKs.
That's great. Let's see.
And this is something that we were really adamant about, as we have the JavaScript already. It's working really well for our users. We want to open up to more languages, and this is why we have the SDK for Microbit, the SDK for the Raspberry Pi, where you can actually use different programming languages depending on what you're trying to learn or what you're comfortable with.
So here's another one from Carl. So I love the programmable aspects, but my favorite way to play with the kids is just to drive it around. With Rover, will it work with the standard Sphero driving app, as I can drive around and change the LED colors? We covered that a little bit, but maybe you could talk about like just the driving experience and what it's like just for fun.
So within the EDU app, you can simply just drive Rover around using just the standard joystick that we'll have available, as well as just turning the LEDs on and off and changing the colors and things like that. So that's really your basic driving experience. And from there, if you want, I think a great way to continue that fun journey and tying a little bit of an education aspect to it is draw mazes, tape out mazes on the floor, and start learning block programming with your kids and introduce them to block programming and saying, okay, now we were just free-form driving it with a joystick, but now, figure out how we can solve a maze using the block programming.
And I would say that because there's so much torque built in the Rover, you have actually the ability to climb over some very much taller obstacles, which is really fun to watch when the robot just like kind of slowly makes its way up a very steep hill, and that's just something that's really driving the wanting to learn and that kind of stuff. So we've seen that in schools. We've seen that here at the office where we drive Rover on some pretty tough obstacles, and it just like magically goes over them, no problem. And that's really entertaining to see and watch.
That's cool. All right, so let's see. We'll take our last couple questions and then wrap up here.
Sounds good.
So let's see. Webcam support planned on the official app. This is actually from the same guy, Ranch, crushing it.
Nice.
So webcam support, is that planned on the official app? And then also, what language do you write your SDK on? So maybe those.
Sure. So again, on the webcam support, so that Raspberry Pi supports a PiCam pretty much out of the box. It's really simple to hook up. So we'll have some samples of how you actually go about getting that connected and set up on your Rover. And then for the second question, what language did we write the SDK in? So the SDK is actually written in multiple languages. So we got C++, we have some Objective-C and Swift for iOS, we have Java for Android. Let's see what else we got. We got some C# for Windows. We got JavaScript and TypeScript. We have Python. I'm sure I'm forgetting one or two or three others that we're using, but it's actually we build our SDKs depending on the platform. We're using a lot of different languages.
And this is really for everyone to be able to start in a place where they have already decided that we're going to go. So if it's JavaScript, if it's Python, if it's C++, you can actually go there and use the classes that you had before or the knowledge that you've built throughout the years and get your hands on the product.
Yeah, and so with the SDKs that we're releasing, again, so those are Arduino, so that one will be C, C++, Microbit, which again is Python, which is MicroPython actually, and TypeScript, and then Raspberry Pi is Python as well as TypeScript.
Awesome. Well, thank you guys so much. We're going to wrap up here, and I just want to remind you, Rover is for sale right now on Kickstarter at a very low price with very limited quantities, so be sure to go check that out. And thank you guys so much for tuning in, and we will be doing another live stream next Wednesday with our founder, Adam Wilson, and he's going to be actually walking us through setting up a Raspberry Pi and building some really cool projects, so make sure to check that out. Thank you guys so much.
We're looking forward to see you guys there. Thanks a lot. Have a good one.
Thanks, guys. Bye.